Let's address several questions regarding ground fault circuit interrupter receptacles, or GFI receptacles, wiring practices, and code requirement. First question concerns GFI receptacle bonding. It's important to clarify that the statement suggesting that ENT or flexible metal conduit negates the need for bonding GFI receptacles is incorrect. The National Electrical Code, specifically the 2020 edition, mandates that all GFI receptacles must be bonded to the equipment grounding conductor, irrespective of the type of conduit used. This is a critical safety measure to ensure proper grounding and fault current paths. Now let's discuss backstab receptacles. There's another potentially misleading statement regarding Underwriters Laboratories, or all, listed backstab receptacles. Post-1995 receptacles are indeed listed to accept both number 14 American wire gauge or AWG and number 12 AWG wire. This provides flexibility in wiring installations accommodating different circuit requirements. Regarding the practice of slaving GFI receptacles, there isn't a specific code provision that restricts the number of receptacles that can be slaved off a single GFI. However, it's generally advisable to limit the number of slaved receptacles to around 5 or 6. Exceeding this number can potentially compromise the reliability and sensitivity of the GFI protection, increasing the risk of nuisance tripping or delayed response to ground faults. The question touches on an interesting scenario where someone wants to install 7 GFI receptacles on a single circuit in a kitchen, given that there are two 20-amp circuits available. Installing 7 GFI receptacles on a single circuit might be considered excessive, and it may be more prudent to distribute the load between the two available 20-amp circuits. This approach can enhance system reliability and prevent overloads. Also, it is mentioned there is concern about why an ordinary receptacle is allowed below a kitchen sink for the disposal appliance, while general-purpose receptacles cannot be installed within 6 feet per National Electrical Code Section 210.87. National Electrical Code Sections 210.86 and 210.87 address ground fault circuit interrupter protection for receptacles in specific locations. National Electrical Code Section 210.86 specifically allows receptacles to be installed under sinks for appliances such as garbage disposals. This allowance recognizes the practical need for a receptacle in that location for a specific appliance. National Electrical Code Section 210.87 addresses general-purpose receptacles. It mandates ground fault circuit interrupter protection for all 125V through 250V receptacles rated 50 amps or less installed in specific locations, including kitchens and within 6 feet of the outside edge of sinks. However, there is an exception for receptacles installed for specific appliances, such as dishwashers or disposals, provided they are located within the space occupied by the appliance. To clarify, the exception in National Electrical Code Section 210.86 overrides the general restriction in National Electrical Code Section 210.87 specifically for receptacles installed under sinks for garbage disposals. This means that a standard receptacle can be installed for a garbage disposal under this sink even if it is within 6 feet of the sink's edge, because it falls under the exception for appliance receptacles. In summary, the exception in National Electrical Code Section 210.86 permits the installation of receptacles under sinks for garbage disposals, regardless of their proximity to the sink, while National Electrical Code Section 210.87 requires ground fault circuit interrupter protection for general-purpose receptacles within 6 feet of sinks, unless they are covered by a specific exception for appliances. Now let's cover some additional information about GFCI receptacles. A ground fault circuit interrupter, or GFCI, is a crucial safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing through a circuit and quickly interrupting the power supply if it detects any imbalance, which could indicate a ground fault. Ground faults occur when electricity deviates from its intended path and flows through an unintended conductor, such as a person's body, to reach the ground. This can happen if insulation on a wire is damaged, exposing the live conductor, or if there's a short circuit in an appliance. GFCI receptacles are designed to detect even small imbalances in current, typically as low as 5 mA. When such an imbalance is detected, the GFCI trips, interrupting the circuit within milliseconds, which is fast enough to prevent serious injury or electrocution. GFCI receptacles are commonly installed in areas where there's a higher risk of electrical shock, such as bathrooms, kitchens, garages, and outdoor locations. These areas are more likely to have wet or damp conditions, which can increase the risk of electrical shock if there's a ground fault. The National Electrical Code, or NEC, mandates the use of GFCI protection in these areas to ensure electrical safety. GFCI receptacles have two buttons on their face, a test button and a reset button. The test button is used to periodically check the functionality of the GFCI. When pressed, it simulates a ground fault, causing the GFCI to trip and cut off power to the circuit. The reset button is used to restore power to the circuit after a ground fault has been detected and the GFCI has tripped. To ensure proper operation, GFCI receptacles should be tested monthly. This helps verify that the device is functioning correctly and will provide protection in the event of a ground fault. If a GFCI fails to trip when the test button is pressed, it should be replaced immediately. GFCI receptacles are available in various configurations, including standard receptacles, circuit breakers, and portable units. Standard GFCI receptacles are designed to replace existing receptacles and provide GFCI protection at the specific location. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. Portable GFCI units are used for temporary applications, such as construction sites or outdoor events, where GFCI protection is needed but permanent installation is not feasible. When installing GFCI receptacles, it's essential to follow the manufacturer's instructions and local electrical codes. The installation should be performed by a qualified electrician to ensure proper wiring and grounding. It's also important to label the GFCI receptacle to indicate that it provides GFCI protection. This helps inform users that the receptacle is protected and should be tested regularly. GFCI protection is not a substitute for proper grounding. Grounding provides a safe path for fault current to flow back to the source, helping to prevent electrical shock and equipment damage. GFCI protection supplements grounding by providing an additional layer of protection, especially in situations where grounding may be compromised or ineffective. In addition to GFCI receptacles, arc fault circuit interrupters, or SIs, are another type of safety device used in electrical systems. SIs are designed to detect arc faults, which are dangerous electrical arcs that can occur due to damaged or deteriorated wiring. Arc faults can generate excessive heat and are a leading cause of electrical fires. SIs work by monitoring the electrical waveform and detecting patterns that indicate the presence of an arc fault. When an arc fault is detected, the SI trips, interrupting the circuit and preventing a fire from starting. SIs are typically installed in the electrical panel and provide protection for the entire circuit. The NEC requires SI protection in many areas of the home, including bedrooms, living rooms, and dining rooms. SIs and GFCIs provide complementary protection against different types of electrical hazards. GFCIs protect against electrical shock by detecting ground faults, while SIs protect against electrical fires by detecting arc faults. Together, these devices help create a safer electrical environment for homes and businesses. When troubleshooting GFCI receptacles, there are several common issues that may arise. One common issue is nuisance tripping, where the GFCI trips frequently without any apparent reason. Nuisance tripping can be caused by various factors, including faulty appliances, loose wiring, or excessive moisture. To troubleshoot nuisance tripping, start by unplugging all appliances connected to the GFCI protected circuits and then reset the GFCI. If the GFCI holds, plug in each appliance one at a time until the GFCI trips again. The appliance that causes the GFCI to trip is likely the source of the problem and should be repaired or replaced. Another common issue is a GFCI that won't reset. This can be caused by a ground fault condition, a faulty GFCI receptacle, or a wiring problem. To troubleshoot a GFCI that won't reset, first, ensure that there are no obvious ground faults such as water near electrical outlets or damaged wiring. Then try resetting the GFCI again. If it still won't reset, try replacing the GFCI receptacle with a new one. If the new GFCI also won't reset, there may be a wiring problem that requires further investigation by a qualified electrician. Another important aspect of GFCI protection is understanding the difference between load and line terminals. GFCI receptacles have two sets of terminals, line terminals and load terminals. The line terminals are where the incoming power from the electrical panel is connected, while the load terminals are where the downstream wiring to other receptacles or devices is connected. When installing a GFCI receptacle, it's crucial to connect the wires to the correct terminals. Connecting the wires to the wrong terminals can result in the GFCI not functioning properly or even causing a short circuit. Typically, the line terminals are marked with the word line, while the load terminals are marked with the word load. If the terminals are not clearly marked, consult the manufacturer's instructions for guidance. Another important consideration is the ampacity of the circuit. The ampacity of a circuit is the maximum amount of current that the circuit can safely carry. It's essential to ensure that the ampacity of the circuit is sufficient to handle the load of all the devices and appliances connected to it. Overloading a circuit can cause the circuit breaker to trip or even lead to a fire. The ampacity of a circuit is determined by the size of the wires and the rating of the circuit breaker. The NEC provides guidelines for determining the appropriate wire size and circuit breaker rating for different types of circuits. When adding new receptacles or devices to a circuit, it's essential to calculate the total load and ensure that it does not exceed the ampacity of the circuit. If the load exceeds the ampacity, it may be necessary to upgrade the wiring or add a new circuit. When working with electrical wiring, it's essential to follow safe work practices to prevent electrical shock and other hazards. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and rubber gloves. Never work on electrical wiring in wet or damp conditions. If you're not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the work. They have the knowledge, skills, and equipment to perform the work safely and correctly. Here's some more information about specific NEC code sections that relate to GFCI receptacles. NEC 210.8 covers GFCI protection for personnel and dwelling units. This section specifies the areas in dwelling units where GFCI protection is required, including bathrooms, garages, and outdoor locations. NEC 210.8b covers GFCI protection for personnel in other than dwelling units. This section specifies the areas in commercial and industrial locations where GFCI protection is required, including wet locations, healthcare facilities, and industrial establishments. NEC 210.12 covers arc fault circuit interrupter protection. This section specifies the areas in dwelling units where off-site protection is required, including bedrooms, living rooms, and dining rooms. NEC 406.4d covers replacement of receptacles. This section specifies the requirements for replacing receptacles, including the use of GFCI protection in certain situations. NEC 406.9 covers receptacles in damp or wet locations. This section specifies the requirements for receptacles installed in damp or wet locations, including the use of weather-resistant receptacles and GFCI protection. NEC 517.20 covers general care areas in healthcare facilities. This section specifies the requirements for electrical wiring and equipment in general care areas of healthcare facilities, including the use of GFCI protection. NEC 547.9 covers agricultural buildings. This section specifies the requirements for electrical wiring and equipment in agricultural buildings, including the use of GFCI protection in certain locations. NEC 555.3 covers marinas and boatyards. This section specifies the requirements for electrical wiring and equipment in marinas and boatyards, including the use of GFCI protection for receptacles. NEC 625.22 covers electric vehicle charging systems. This section specifies the requirements for electrical wiring and equipment used for electric vehicle charging systems, including the use of GFCI protection. Let's delve further into ground fault circuit interrupter protection. One key concept is the ground fault itself. A ground fault occurs when there is an unintentional electrical path between a live conductor and ground. This can happen due to damaged insulation, water intrusion, or other factors that create a conductive path. When a ground fault occurs, current can flow through unintended paths, posing a risk of electrical shock or fire. GFCI receptacles are designed to detect these ground faults and quickly interrupt the circuit, preventing injury or damage. The sensitivity of a GFCI is typically around 5 mA. This means that the GFCI will trip when it detects a current imbalance of 5 mA or more. This level of sensitivity is sufficient to protect against electrical shock, as even small amounts of current can be dangerous to humans. GFCI receptacles work by monitoring the current flowing through the hot and neutral conductors. In a normal circuit, the current flowing through the hot conductor should be equal to the current flowing through the neutral conductor. However, when a ground fault occurs, some of the current will flow through an unintended path to ground, creating an imbalance between the hot and neutral currents. The GFCI detects this imbalance and trips, interrupting the circuit. The tripping time of a GFCI is typically very fast, usually within milliseconds. This rapid response time is crucial for preventing serious injury or electrocution. The faster the GFCI trips, the less time there is for current to flow through a person's body, reducing the severity of the electrical shock. GFCI receptacles are designed to be self-testing. They have an internal circuit that periodically checks the functionality of the GFCI. If the GFCI detects a problem with its internal circuitry, it will trip, indicating that it needs to be replaced. It's important to test GFCI receptacles regularly to ensure that they are functioning properly. The test button on the GFCI simulates a ground fault, causing the GFCI to trip. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. GFCI receptacles have both line and load terminals. The line terminals are where the incoming power from the electrical panel is connected, while the load terminals are where the downstream wiring to other receptacles or devices is connected. When installing a GFCI receptacle, it's important to connect the wires to the correct terminals. Connecting the wires to the wrong terminals can result in the GFCI not functioning properly or even causing a short circuit. GFCI protection can be provided in several ways, including GFCI receptacles, GFCI circuit breakers, and GFCI cord sets. GFCI receptacles are the most common type of GFCI protection and are typically installed in place of standard receptacles. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. GFCI cord sets are portable GFCI devices that can be plugged into a standard receptacle to provide GFCI protection for temporary applications. When selecting GFCI protection, it's important to choose the right type for the application. GFCI receptacles are suitable for providing protection at specific locations, while GFCI circuit breakers are suitable for providing protection for entire circuits. GFCI cord sets are suitable for temporary applications where portable GFCI protection is needed. GFCI protection is not a substitute for proper grounding. Grounding provides a safe path for fault current to flow back to the source, helping to prevent electrical shock and equipment damage. GFCI protection supplements grounding by providing an additional layer of protection, especially in situations where grounding may be compromised or ineffective. When troubleshooting GFCI protection, there are several common issues that may arise. One common issue is nuisance tripping, where the GFCI trips frequently without any apparent reason. Nuisance tripping can be caused by various factors, including faulty appliances, loose wiring, or excessive moisture. To troubleshoot nuisance tripping, start by unplugging all appliances connected to the GFCI protected circuit and then reset the GFCI. If the GFCI holds, plug in each appliance one at a time until the GFCI trips again. The appliance that causes the GFCI to trip is likely the source of the problem and should be repaired or replaced. Another common issue is a GFCI that won't reset. This can be caused by a ground fault condition, a faulty GFCI receptacle, or a wiring problem. To troubleshoot a GFCI that won't reset, first ensure that there are no obvious ground faults such as water near electrical outlets or damaged wiring. Then try resetting the GFCI again. If it still won't reset, try replacing the GFCI receptacle with a new one. If the new GFCI also won't reset, there may be a wiring problem that requires further investigation by a qualified electrician. SI or arc fault circuit interrupters offer further fire prevention.